Now we are discussing a concept of electronic configuration suggested by Niels Bohr that is called as Aufbau principle. This is something German word, Aufbau. The meaning is that to fill up. So how electrons are filled up in the atom. Now in previous part we discussed that there are shells n equal to 1, n equal to 2, n equal to 3. Even that shells are having name n equal to 1, that means K, n equal to 2, that is L, like that. But that configuration is not that much sufficient because that is applicable approximately till atomic number 20, that is applicable. But further to that we require some different chart. So I am showing you here right now the chart. Try to understand first, because at end we are going to discuss in detail once again with other data. So right now we are making a chart that is called as Aufbau principle. Now here how electrons are arranged in the shells. For that purpose this chart is there. But how? That is shell, then there are subshells and capacities of that. So that we are going to discuss right now. You are aware that people in different part of world, they discover different styles of writing. Say for example in India, we are writing this way, from left to right. In Europe also, people are writing this way only, that left to right. But in Arabian subcontinent, Persia, they are writing from right to left, like Urdu, or ancient Indian script that is called as Kharoshtri. But that was not Indian script, that was introduced by Persian people, particularly in the valley of Indus. This script was introduced, that is called as Kharoshtri script during Hakhamani Empire. Japanese people, you are aware, they are writing. Actually, if I am writing this way, then I should call this right. But if I am writing this way, then what I should call? But Japanese people are writing in this way, top to bottom. Whereas chemist now writing from bottom to top. Now what Aufbau principle is there? For that purpose various charts and various methods are available. I am teaching you only one method because my suggestion is that follow only that one method. Otherwise lots of confusion people are doing and ultimately they are making atomic catastrophe. So forget of that, try to follow only one method. Now I will show here that method. So first, the orbits, irrespective of they are n equal to 1, n equal to 2, 3, like that, they are given, distributed in the format S, P, D, F. They are subshells of every atom, every orbit. S is having capacity 2. It is written on superscript. Superscript means above this, and that is in also form of small part. But don't read this as S square. While reading, we have to read as S2. The method is this: P 6, D 10, and F 14. Again telling these are the maximum capacities of electrons in the suborbit or subshell. So these are the capacities I have mentioned over here. Now how to write? It is 1s. I will start from this way. 1s. 1 indicate first orbit, s indicates subshell. Then 2s. After 2s, I will write here 2p. Say for s, pdf, sorry, for first 1, pdf is not there. For 2, it is only p. So s as well as p. 3s, 3p, 3d. 4s, 4p, 4d, 4f. See, every time I am increasing one orbital. So here S, then P, then D, and then F is last. Then 5S, 5P, 5D, 5F. May be possible they are there, but whatever total atoms available today, they are having only this much. 6S, 6P, 6D, 6F. 7S, 7P, 7D, 7F. That's all. This is first, we are writing out all these orbitals clearly. So when I am saying 5D, it indicates main shell number 5, subshell D. Capacity of D is 10, it is written. Now we have to join this. So we have to put a track, and like that we are arranging them in the track. So first track, second track, only one station here, only one station here. Now third track having two stations. While you are going to writing out, at that time you should not write 1, 2, 3. Only draw lines. In some book they are showing lines this way, but over after that coming this way, and like that. But it is making diagram more complicated. Instead of that, keep in mind, travel from here to here, and then go to next track, go to next track, fourth, fifth, sixth, don't miss out anything, 7, otherwise what happens that sometimes some letters are missing out, 8, 9, and lastly only 1, 10. Now, how to carry out electronic configuration? Let us perform it for sodium. So I am writing here sodium, atomic number 11, mass number 23. We discussed this. How many electrons are there in sodium? Answer is 11. Why? Because this is atomic number. Now I have to arrange 11 electrons here. In previous part we discussed how electrons are arranged according to KLM. But now we are going to discuss in detail. So I have to assign 11 electrons. So I will follow this track, track number 1. It is 1s. So I will write 1s. How many electrons can be accommodated in s orbit? Answer is maximum 2. So I will write here 2. Because I have 11 electrons to fill. Out of that 2 we have filled out. Next track 2s. See, we are following this track, ended. Now start next track. Only one station is there. Write down 2s. What is the capacity of s? Again 2. So write down 2. Don't read 1s square. Read 1s 2. 2s 2. Then go to third track. You will find 2p. So in 2p we can fill 6 electrons. Capacity is 6. Reminder 1. So check out, it's 2 plus 2, 4 plus 6, 10. So after 2p there is 3s. So write down 3s, and no doubt capacity is of 2, but available electron is only 1. Therefore write down it as 1. So this way we have mentioned that electrons in sodium, they are like this. Now the previous questions. In previous session only we have out that why electronic configuration of calcium is 2882. Why not 2, 8, 5 and 5? Okay, that answer we are going to find out here. Calcium, atomic number 20, mass number 40. That means how many electrons are there? 20. Now we have to fill 20 electrons here. So I have to follow this chart, 1s2. then go to second track 2s2, then third track 2p6, after that 3s2. Keep eye on the number of electrons, so it is 10 plus 2, 12. I have to accommodate 20 electrons. So 12 electrons already accommodated till 3s. Then go to next track, fourth track, we'll get 3p. So 3p, 6. Now number of electron 10 plus 6, 16 plus 2, 18. So 18 electrons are filled here till 3p. Many students are committing mistake in general. They after 3p they write 3d. So this is not this way we have to go. That's why I have produced track here. So after 3p, go to this line, you will get there 4s. And therefore it is 4s. And we have 2 electrons, so I am filling out. Now is it according to previous configuration? Answer is definitely yes. You are aware sodium configuration is 281. Let us check. First shell, only 2 electrons are there. Second shell, 2 plus 2, that is second shell, 2 plus 6, 8 electrons are there. And last shell, only third shell is last 1. So electronic configuration is according to previous, 281. Let us go for a calcium. First shell only 1. So write down 2. Second shell, 2s and 2p. So 2 plus 6, 8. Third shell, 3s and 3p. Total 2 plus 6, 8. And fourth shell, 2. Getting idea? That's why the configuration is 2882 and not and not 2855 or any probability of that. So here it is clearly mentioned according to Aufbau principle. So Aufbau principle is actually a fantastic way to give electronic configuration of an element. So this is performed by me. Now you have to perform. Obviously take this down, pause this video, take this all chart, because you have to produce this chart your own. Produce that, and then after writing these 2 examples, go for the most complicated here. Carry out electronic configuration of uranium yourself, atomic number 92, mass number 238. Try to do it yourself. Your what we can say management skill, calculation skill, like that, and patience. Everything is tested here. Try to carry out electronic configuration of uranium. One more spoon feeding. You are aware how many electrons are there now? 92. You have to fill 92 electrons now. Start electronic configuration of uranium now. You are aware that your skill, that management skill and all calculation skill, they are playing important role here. So I will write here in a somewhat smaller size, because I have to accommodate totally 92 electrons. As atomic number of uranium is 92, we have to accommodate 92 electrons. So 1s2, C, 1s2, then 2s, 2s2, then third track 2p6, 3s2, next track 3p6, then 4s2. So after 3p, again I am telling, 3d is not filled. After 3p it is 4s. Now fifth track 3d 10. I will keep here only 3d 10, and I will get total of all. So 10, 10, 20, 10, 30. So here I will write total 30. So yet 62 electrons to fill. So after 3d it is 4p. So I will write here from 4p 6. Then 5s2. Now sixth track 4d 10. 5p6. 6s2. Okay. Then we are going to 7th track, where we will get 4f14. Then 5d 10. So So I will make total here only, that is 6 plus 2, 8, 18, 24, 26, 30, 40, 50. So total is 80. So remainder 12. So 5D. Then I will go to 6P. 6P is 6. Remainder is 12. Out of that 6. 7 is 2. 8. So remainder is here 12. Out of that 8 is there. That means remainder is 4. After 7 is, we are going to next track, that is 5F. No doubt 5F I can write 14. But I don't have electron. Electrons are only 4. So I have to write here 4 electrons. And then you can check the total. 6 plus 2, 8 plus 4, 12. Total is 2, 5 plus 1, 6 plus 3, 9. 92 is the total. So this way we carried out electronic configuration of uranium. With skill, certain skills, not high class, but these skills are important. This is the way we are carrying out electronic configuration of uranium. But after making this type of huge electronic configuration, we want to assign them. How? I have to assign like that according to number. First shell first, second, third, like that. Let me clarify. Here I will collect only 1s is there. So I will write 1s, 2s, 2p, alright, 3. It is 3s2, 3p, 6. I have one last time that after 3p it is 4s. Then it is 3d. But here I have to arrange all 3 together. And therefore, after carrying out this configuration, I am assured, then only I am writing 3d 10. Now 4s2, check out 4s, 4p, 4d, 4f. So I will write 4s2, 4p 6, 4d 10, 4f 14. After that 5s. So 5s2, 5p 6, 5d 10, and last 5f 4. Now 6 shell, it is 6s2, 6p 6, 6d not under construction. So keep it as it is, and 7s. You will come to know this is called as shell under construction, whereas last shell is 7s2 or 7 remain unchanged. Let me clarify. Would you like to carry out one more electronic configuration? Next element of uranium is neptunium, atomic number 93. That means what? You have to fill up 93 electrons. So right now you fill up with so many. Only one electron you have to add. Where you are going to add? 5f5. Next element of neptunium is plutonium, 5f6. That means this is called as shell under construction. Okay. So last shell remains same, second last shell remains same, and electrons are added in third last shell. This is the peculiarity of uranium. Therefore, it is called as inner transition element. You might have noticed that when usually we describe periodic table, we say that if last 3 shells are incompletely filled in, we are calling them as inner transition element. Question is always there in mind that if all earlier shells are filled first and then higher shells, then why this is the situation? Why 3 shells are remaining semi-filled? The thing is that according to Aufbau principle, this is the way, and therefore uranium is having last 3 shells incompletely filled. Shell under construction is third last, whereas second last and last shell remain unchanged. So I hope you might have carried out all these electronic configuration nicely. After successfully carrying out electronic configuration of uranium 92 and neptunium 93, plutonium 94, I will give you somewhat simpler task to do. Now carry out electronic configuration of phosphorus, atomic number 15, mass number 31. So try to do electronic configuration of phosphorus. Now you may say that it is quite easy after observing this all. Say we have to accommodate only 15 electrons. First pause this video, try to make yourself, then I will do. So 15 electrons I have to accommodate, 1s2, 2s2, 2p6, 3s2, remainder 10 plus 2, 12, 15 electron, that means remainder 3. So electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p3. So this is the way electronic configuration of phosphorus. Now if you are going this way, you will find it is easy. So first we have carried out simpler task, then tough task, and then again simpler task. But life is not so simple as we are thinking. So here another rule is applicable and we are going to do that. That is called as Hund's rule of maximum multiplicity. What that called as Hund's rule of maximum multiplicity. That says that when degenerated orbitals are available. First let me clear you the concept degenerated orbitals. Degenerated orbitals means orbital having same energy level. Then they are called as degenerated orbitals. Now here, if I am saying these two orbitals, let us check, this is 3s. Graphically I will show this. Now 3p. Graphically I will show 3p orbital is divided into 3 parts. Whereas this is called as energy gap. So 3s2. So this is first electron, second electron. Now here question is that why I have shown this way? Because electron is shown, it is revolving around nucleus, but at the same time it is having spin motion. It is revolving, rotating around its axis also. You are aware that planets, they are revolving around sun in our solar system. But at the same time, they are revolving around their axis also. Same way, electrons are also revolving around their axis. In case of planet, is it possible that all planets revolve in same direction? Answer is no. You will get surprising data that Venus and Uranus, these two planets revolve in reverse way. Means Earth rotates, rotate. Earth rotates from west to east direction. Am I wrong? I am revising. Earth rotates west to east direction. That's why you will find that sun is rising at east and setting at west. So Earth rotates from west to east. Many planets rotate in same way, but Venus and Uranus, though they rotate in exactly opposite way, means they will rotate from east to west. Alright, so this is the case. So electron also rotate clockwise as well as anti-clockwise. So here, by indicating this type of arrow, I am indicating electron rotating clockwise. By indicating this arrow, I am rotating electron indicating anti-clockwise. So this way we are showing spin of electron, that is clockwise and anti-clockwise. Now according to the principle of magnetism, any charged body is in motion. I am revising. Any charged body is in motion. It is going to produce magnetic field around it. So electron is a charged body. It is rotating also. That's why it is producing magnetic field around it. The clockwise spin will produce different magnetic field. Anti-clockwise will produce different magnetic field. Opposite magnetic fields are there, therefore there is attraction. And that's why in an orbital, 2 electrons can be accommodated. But always keep in mind, one will spin clockwise, then other must spin anti-clockwise. Parallel spin is not an energically stable condition. So here, I should not say both are clockwise or both are anti-clockwise. I have to say show one is clockwise, other is anti-clockwise. Now, p orbital, according to data, I will explain in some other lecture, but this is called a Zeeman effect and Stark effect. So in order to accommodate that, they say that p orbital is subdivided into, according to say x-axis is there, then we are calling it as 3px orbital. According to y orbital, then we are calling it as 3py orbital. And according to z orbit, z-axis, it is called as 3pz orbital. So this way, now I am changing this 3s to 3p3 in format of 3s box, 2 electrons, 3px, 3py, 3pz. Now, as here is energy gap, we are not saying these orbitals are degenerated. But as here there is no energy gap, so px, py, pz, we are considering degenerated orbital. That means they have same energy. Now, first electron, how many electrons I have to accommodate? 3. First electron, I will say this way. Second electron, actually I should show this way. But no. Why? Because there is space available. So why to go here? So second electron will remain independent. Third electron will also remain independent. Instead of pairing out, they will try to remain unpaired as far as possible. Hund's rule is saying this same thing. When degenerated orbitals are available, electron will try to remain unpaired as far as possible. So, how we are going to modify this configuration? So, this configuration I am rewriting 1s2, 2s2, 2p6, 3s2 is unchanged here. I will write this way, but p I am now splitting this way, that 3px1, 3py1, 3pz1. Don't say 3p x1, y1, z1, because in mathematics we have habit of making common. So in 3px, 3py, 3pz, take 3p common, x, y, z. So don't do that. Because these are the names of orbital, and we can't say that with names of orbital something we can take common. So this is 3px, 3py, 3pz. This way we can do electronic configuration of phosphorus. Now, next element you will try first, then I will try chlorine, atomic number 17. So first try yourself. I am just writing here chlorine, atomic number 70. Mass number suppose 35. We are going to discuss electronic configuration of chlorine. So now your experience 1, 1s2, 2s2, 2p6, 3s2, 3p5. So according to Aufbau principle, this is our electronic configuration. This is according to Aufbau principle. Now we have to apply this Hund's rule of maximum multiplicity. So I have to check for 3p5. So in case of this, first electron, second, third, but now there is no place for fourth electron to go. And then pairing is possible, but in reverse way. Now not necessary electron should go in X only. It may go in Y, it may go in Z, anywhere. But we have to consider alphabetically for sake of convenience. So we are saying fourth electron is going this way, fifth electron will go this way. Okay. Whereas there is no sixth electron, so no question. So I will modify this configuration as 3p x2, 3p y2, 3p z1. So this way we are modifying chlorine. Keep in mind Hund's rule of maximum multiplicity that is used when p, d or f, these orbitals are last orbital and they are incompletely filled. Okay. For argon, no need to explain. Argon is having atomic number 18. So you can write down simply 3p6. Okay. But if you are talking of incompletely filled orbital, then this is required. So this is we are discussing about electronic configuration, and we just studied out Hund's rule of maximum multiplicity.